China's Lunar Exploration Plan for the next 10 years. China's Lunar Exploration Initiative, known as the Chinese Lunar Exploration Program (CLEP) or Chang'e program, is set to advance significantly over the next decade. Under the direction of the China National Space Administration (CNSA), the program will focus on both robotic and crewed missions designed to enhance our understanding of the Moon and develop technologies for future exploration. Overview of phases and upcoming missions. The CLEP is structured in 4 operational phases, each aimed at progressively more complex lunar activities. Phase 1: Robotic Orbital Missions. This initial phase is complete with the successful launches of Chang'e 1 and Chang'e 2, which provided detailed maps of the lunar surface and valuable data for future missions. Phase 2: Soft Landers and Rovers. This ongoing phase includes several critical missions. Chang'e 3 2013 deployed the Yutu rover to explore the lunar surface. Chang'e 4 2019 achieved the first soft landing on the far side of the Moon, also deploying the Yutu 2 rover. Chang'e 5 2020 successfully returned lunar samples to Earth for the first time in over 40 years. Phase 3: Sample Return Missions. The next mission, Chang'e 6, is scheduled for launch on May 3, 2024, aiming to collect samples from the far side of the Moon, specifically from the Apollo Basin. This mission will build on the success of Chang'e 5. Phase 4: Lunar Robotic Research Station. A significant focus of the program is the development of a lunar research station, particularly near the Moon's south pole. The upcoming missions Chang'e 7 and Chang'e 8 are planned for 2026 and 2028 respectively. Chang'e 7 will explore resources while Chang'e 8 will test technologies for in-situ resource utilization and 3D printing capabilities. Crewed lunar missions. China's crewed lunar exploration is projected to begin by 2030. This will utilize the new Mengzhou spacecraft, meaning Dream Vessel, and the Lanyue lunar lander, meaning Embracing the Moon. The Mengzhou spacecraft is designed to carry up to 6 astronauts and will replace the existing Shenzhou spacecraft. The Lanyue lander will facilitate the landing and return of astronauts from the lunar surface. Key milestones for the crewed missions include 2024, ongoing development of the Lanyue lander with propulsion system tests already completed. 2029 to 2030, the first crewed lunar landing is scheduled, where 2 astronauts will conduct scientific research and return lunar samples to Earth. International cooperation. China's lunar program is marked by significant international collaboration. Past missions have included payloads from various countries, and formal partnerships with Russia are being established for the construction of a lunar research station, presenting an alternative to NASA's Artemis program. Timeline of key events. 2007, launch of Chang'e 1, marking the start of the CLEP. 2013, Chang'e 3 lands on the Moon, deploying the Yutu rover. 2018, Chang'e 4 achieves the first far-side landing. 2020, Chang'e 5 returns lunar samples to Earth. 2024, launch of Chang'e 6 for sample collection from the far side. 2026, launch of Chang'e 7 for exploration of the lunar south pole. 2028, expected launch of Chang'e 8 to test lunar base technologies. 2030, target year for the first crewed lunar mission. Conclusion. China's comprehensive lunar exploration plan for the next decade emphasizes a combination of robotic and crewed missions with a focus on scientific discovery and technological advancement. Through international collaboration and a clear timeline of milestones, the CLEP aims to establish a sustained human presence on the Moon while expanding our understanding of lunar resources and geology. The integration of advanced technology and research capabilities positions China as a vital player in the forthcoming era of lunar exploration. China's lunar exploration plan for the next decade is characterized by ambitious goals and a structured approach through the Chinese Lunar Exploration Program (CLEP), also known as the Chang'e program. Here are several counterintuitive points regarding this program. 1. Focus on lunar resources despite precedent. While many nations have previously focused on lunar exploration primarily for scientific discovery, China's emphasis on resource utilization, particularly in its Chang'e 7 and Chang'e 8 missions, indicates a shift towards practical applications. This is counterintuitive, as one might expect initial lunar missions to prioritize pure scientific research rather than resource extraction. 2. International collaboration over competition. Typically, space exploration is viewed as a competitive arena among leading spacefaring nations. However, China has actively sought international partnerships such as formal agreements with Russia for a lunar research station and collaborations with various countries for payloads in its missions. This cooperative stance contrasts with the competitive narrative often associated with space exploration. 3. Rapid development of crewed missions. Many experts believe that crewed lunar missions were a long-term goal for China, potentially decades away. However, the announcement of a crewed lunar landing as early as 2030 shows a much more accelerated timeline than anticipated, highlighting China's readiness to undertake these missions sooner than many analysts expected. 4. Integration of advanced technologies. The planned use of technologies such as in-situ resource utilization and 3D printing on the lunar surface, as seen in the Chang'e 8 mission, represents a significant leap in thinking. Traditionally, early lunar missions have not incorporated such advanced tech for immediate application, instead focusing on exploration. This forward-thinking approach suggests a strategic pivot towards establishing a sustainable human presence on the Moon. 5. Public engagement in naming spacesuits and rovers. The Chinese space agency's call for public input in naming initiatives for their lunar rover and EVA suits is unconventional. Typically, such decisions are made internally by agencies without public involvement. This strategy reflects a surprising openness and may serve as a means to foster greater public interest and support for lunar exploration. 6. Lunar research station as a priority. While establishing a lunar base is often viewed as a distant objective, China's plan to develop a lunar research station in the next decade shifts this perspective. Instead of viewing bases as a longer-term goal, China is treating them as an integral part of its near-future lunar strategy. 7. Emphasis on the far side of the Moon. Many countries have focused their lunar missions on the near side, where communication is simpler due to its visibility from Earth. In contrast, China has prioritized missions to the far side, as demonstrated by Chang'e 4 and Chang'e 6, which not only showcase technical capability but also a willingness to tackle more complex challenges in lunar exploration. 8. Anticipating a moon palace. China's vision of a potential lunar base, referred to as a moon palace, may seem fanciful or overly ambitious at first. However, the structured timeline and technology development plans suggest a serious commitment to transforming this vision into reality. This ambition contrasts with the more cautious, incremental approaches typically associated with new space initiatives. These counterintuitive elements reflect a broader strategic vision for China's lunar exploration that seeks not only to advance scientific knowledge but also to establish a sustainable human presence and utilize lunar resources, an approach that may redefine the future of space exploration. China's lunar exploration plan for the next decade is ambitious and multifaceted, with significant implications not only for space exploration but also for international relations, technological advancements, and scientific discovery. While much of the program's details are highlighted, certain aspects are often overlooked, yet they carry substantial significance. 1. International collaboration and competition. While the report mentions international cooperation, particularly with Russia, the broader implications of this collaboration are frequently underestimated. The establishment of a lunar research station in partnership with Russia presents a strategic counterpoint to NASA's Artemis program. This rivalry could reshape global space policy and partnerships, potentially leading to a new era of space exploration that emphasizes bilateral agreements over multilateral ones. The significance lies in the potential for a shift in leadership in space exploration. As the U.S. grapples with its own challenges in space policy and funding, China's focus on international collaboration, inviting participation from countries like South Africa, Belarus, and others, positions it as a leader in a multipolar space environment. This could influence future global space governance, resource sharing, and scientific collaboration. 2. Technological advancements in lunar missions. The focus on advanced technologies such as in situ resource utilization (ISRU) and 3D printing in lunar missions, particularly with Chang'e 8, is often glossed over. These technologies could revolutionize how lunar bases are constructed and sustained. ISRU, for instance, allows for the extraction and use of lunar materials to support human life and operations, reducing the need to transport everything from Earth. The potential for 3D printing on the Moon opens up avenues for constructing habitats, tools, and equipment using lunar regolith, which minimizes payloads and supports sustainable long-term presence. This technology could not only apply to lunar missions but also set the stage for future Mars missions, making it a critical area of development. 3. Environmental considerations in space exploration. The report briefly touches on environmental adaptability and the challenges posed by the Moon's harsh conditions. However, the significance of this aspect should not be understated. As space exploration expands, understanding and mitigating the environmental impact of lunar missions becomes increasingly crucial. This includes not only the sustainability of operations on the Moon but also the implications of space debris and contamination. China's approach to environmental adaptability, designing spacecraft and rovers that can withstand extreme temperatures and radiation, could serve as a model for future missions by other nations. The emphasis on robust designs that can endure the lunar environment reflects a growing awareness of responsible exploration, which will be essential as more countries and private entities venture into space. 4. The role of the Mengzhou and Lanyue spacecraft. The introduction of the Mengzhou crewed spacecraft and the Lanyue lunar lander marks a significant shift in China's capabilities for crewed missions. These spacecraft are designed not only to facilitate lunar landings but also to support long-term exploration, including scientific research and potential colonization efforts. The significance of these vehicles lies in their modular design and the planned use of advanced technologies such as autonomous navigation systems. The development of these spacecraft not only enhances China's crewed spaceflight capabilities but also sets a precedent for future missions, emphasizing the importance of innovation in human space exploration. 5. Cultural and symbolic dimensions of lunar exploration. The naming of the Mengzhou Dream Vessel and Lanyue embracing the Moon spacecraft reflects a cultural narrative around lunar exploration which is often overlooked in technical reports. These names embody China's aspirations and cultural heritage, resonating deeply with the public and inspiring future generations. The narrative surrounding lunar exploration serves to unify national pride and global engagement in science and technology. The cultural significance of space missions can mobilize public support and interest, fostering a new generation of scientists and engineers. Highlighting this aspect could enhance international partnerships by emphasizing shared human experiences and aspirations beyond mere technological competition. 6. Long-term vision beyond the Moon. The report briefly mentions plans for an international lunar base by 2035, but the long-term vision for a sustained human presence on the Moon and potentially beyond should not be overlooked. This vision includes not only lunar exploration but also the potential for Mars missions, which could follow the establishment of a lunar base. The significance lies in the strategic planning for humanity's next steps in space exploration. Establishing a foothold on the Moon could serve as a testing ground for technologies and life support systems necessary for Mars missions and beyond. This foresight positions China as a serious contender in the race for interplanetary exploration. Conclusion: China's lunar exploration plan for the next decade is more than a series of missions, it represents a strategic shift in global space dynamics. By fostering international collaborations, investing in advanced technologies, and cultivating a cultural narrative around exploration, China is setting the stage for a new era in space. The implications of these developments extend beyond lunar exploration, influencing international relations, technological innovation, and the future of human presence in space. Understanding these nuanced elements is essential for grasping the full impact of China's ambitious lunar agenda. 1. Comprehensive phased approach to lunar exploration. China's Lunar Exploration Plan, structured into 4 operational phases, showcases a systematic and methodical approach to expand lunar capabilities. Each phase builds on the successes of the previous one, starting from robotic orbiters Phase 1, advancing to soft landers and rovers Phase 2, and moving towards sample return missions Phase 3. The plan culminates in establishing a Lunar Research Station Phase 4, highlighting China's commitment to long-term lunar exploration and habitation. 2. Ambitious crewed lunar missions by 2030. The introduction of crewed lunar missions with a target set for 2030 marks a significant milestone in China's space ambitions. Utilizing the new Mengzhou spacecraft and Lanyue lander, these missions will not only enhance human presence on the Moon but also facilitate scientific exploration and sample collection. This initiative reflects China's strategic goal of becoming a leader in space exploration and its potential to contribute to international efforts in lunar science. 3. International collaboration and partnerships. China's lunar program emphasizes international cooperation, distinguishing it from other national space programs. By incorporating international payloads and missions and formalizing partnerships, especially with Russia for a lunar research station, China aims to foster a collaborative environment in space exploration. This approach not only enhances technological development but also positions China as a key player in global space initiatives, potentially challenging existing frameworks like NASA's Artemis program. For the technological innovations and resource utilization, the planned missions, particularly Chang'e 7 and Chang'e 8, focus on in situ resource utilization and advanced technologies such as 3D printing. These innovations are crucial for sustainable lunar exploration, enabling future missions to harness local resources for construction and life support. The emphasis on developing technologies that can be tested and implemented on the lunar surface indicates a forward-thinking approach vital for establishing a long-term human presence on the Moon and possibly paving the way for future Mars missions. 1. Apollo Program 1961–1972. The Apollo program was a pivotal series of crewed space missions conducted by NASA with the objective of landing humans on the Moon and bringing them safely back to Earth. The program culminated in the historic Apollo 11 mission in 1969, during which astronauts Neil Armstrong and Buzz Aldrin became the first humans to walk on the lunar surface. Over the course of 6 missions, Apollo not only achieved lunar landings but also advanced technology in space travel, which has had lasting impacts on scientific exploration and engineering. The program was a significant demonstration of human capability and international competition during the Cold War. 2. Lunar Program 1959–1976. The Soviet Lunar program was the first to reach the Moon, achieving a series of milestones from robotic missions to crewed lunar landings. It included the first successful impact on the Moon, Luna 2, in 1959, the first soft landing, Luna 9, in 1966, and the first robotic sample return mission, Luna 16, in 1970. The program showcased the Soviet Union's early dominance in space exploration and laid the groundwork for later international lunar missions. The achievements of the Luna program significantly contributed to the scientific understanding of the Moon and spurred subsequent lunar exploration efforts worldwide. 3. Chandrayaan Program 2008–present. The Indian Space Research Organisation ISRO launched the Chandrayaan program to explore the Moon with a series of missions. The first mission, Chandrayaan-1, successfully orbited the Moon and discovered water molecules on the lunar surface, marking a significant achievement for India's space capabilities. Following this, Chandrayaan-2 included an orbiter lander and rover, although the lander failed during its descent in 2019. The program represents India's growing ambition in space exploration and has positioned the country as a key player in international lunar research, fostering collaboration with other nations on future lunar missions. Future outlook: China's lunar exploration plan for the next 10 years. China's Lunar Exploration Program, overseen by the China National Space Administration (CNSA), is poised for significant advancements over the next decade. This plan, known as the Chinese Lunar Exploration Program (CLEP), aims to establish a sustainable human presence on the Moon while enhancing scientific understanding through a series of robotic and crewed missions. Here is a detailed outlook on the upcoming initiatives and milestones expected in the next 10 years. Key phases of the program. 1. Continued robotic exploration. Chang'e 6 2024. Following the successful sample return of Chang'e 5, the upcoming Chang'e 6 mission will target the Apollo Basin on the far side of the Moon, set for launch on May 3, 2024. This mission will further our understanding of lunar geology and facilitate the collection of additional lunar samples, with a return expected by June 2024. Chang'e 7 2026. This mission will focus on exploring resources near the lunar South Pole, utilizing a combination of an orbiter, lander, and mini-flying probe. It is expected to enhance our capabilities in resource exploration, critical for future human missions. Chang'e 8 2028, aiming to test in situ resource utilization technologies and 3D printing capabilities. This mission will lay the groundwork for establishing a lunar research station. The technologies developed will be pivotal in supporting long-term human activities on the Moon. 2. Crewed lunar missions. Introduction of new spacecraft. The Mengzhou spacecraft and the Lanyue lunar lander, set to facilitate human exploration, will play key roles in China's crewed lunar endeavors. The Mengzhou spacecraft will carry up to 6 astronauts, while the Lanyue lander will enable landings on the lunar surface. First crewed lunar landing 2030. China's first crewed lunar landing is scheduled for 2030. This mission will see 2 astronauts conducting scientific research and sample collection on the Moon, marking a significant milestone in China's space exploration history. Technological developments. Launch vehicles. The Long March 10 rocket is under development to support crewed missions, capable of launching both the Mengzhou spacecraft and the Lanyue lander. This vehicle will enhance China's capability to transport astronauts and supplies to the Moon. Lunar rover. A lunar rover capable of supporting crewed missions is also in development, aiming to assist astronauts during their surface operations. This rover will incorporate advanced technologies to navigate the challenging terrain of the Moon. International collaboration. China's lunar program is increasingly characterized by international cooperation. Partnerships with countries such as Russia have been formalized to develop a lunar research station as part of the International Lunar Research Station (ILRS) project. This collaboration is seen as an alternative to NASA's Artemis program and underscores China's commitment to global partnerships in space exploration. Timeline of upcoming missions. 2024, launch of Chang'e 6 for sample collection from the far side of the Moon. 2026, launch of Chang'e 7 for lunar South Pole exploration. 2028, launch of Chang'e 8 to test technologies for lunar base construction. 2030, target year for China's first crewed lunar landing. Strategic goals. 1. Establishing a lunar research station. The culmination of these robotic and crewed missions will lead to the establishment of a research station on the Moon, focusing on sustainable human presence and resource utilization. 2. Scientific advancements. The missions will significantly contribute to our understanding of lunar geology, resource distribution, and the Moon's potential for supporting life and human endeavors. 3. Demonstrating leadership in space. By advancing its lunar program, China aims to position itself as a leader in global space exploration, fostering collaboration while also showcasing its technological capabilities. Conclusion. China's Lunar Exploration Program over the next decade represents an ambitious and comprehensive approach to lunar exploration. With a clear roadmap of missions, the integration of advanced technology, and a focus on international collaboration, China is set to make significant contributions to our understanding of the Moon and its potential for future human habitation. The next 10 years will be pivotal in establishing a sustainable human presence on the Moon, marking a new era in space exploration.